Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Testing and Validation for AI, making sure your AI works as expected. Imagine you're building a fancy new robot chef that can cook amazing meals. You've taught it how to prepare a complex dish. But before you open your robot restaurant, wouldn't you want to asterisk test if it actually cooks the dishes correctly every single time? What if it burns the toast or forgets an ingredient? Testing and validation for AI is exactly that. It's how we, as developers, make sure our AI systems, like our robot chef, actually work as expected, are reliable, and don't make silly or harmful mistakes when they go out into the real world. It's about building trust in our AI. When we test our AI, we're mainly looking for three critical things, like checking off items on a quality checklist. 1. Accuracy. Asterisk, does it give the right answer most of the time? Does the robot chef make the pasta correctly every time? 2. Reliability. Asterisk, does it work consistently every time, even with slightly different inputs? Does it cook pasta well today, tomorrow, and the day after? No matter if the tomatoes are a little riper or the pot is a different size. 3. Fairness and safety. Asterisk, does it avoid unfair biases or unsafe actions? Does it treat all ingredients fairly? And won't suddenly try to cook with toxic items or serve burnt food to specific customers. As a developer, ensuring these means your AI is trustworthy and ready for use. Think of your AI as a student and the data you give it as its textbook and homework exercises. Just like a student needs good quality study material to learn effectively, your AI needs good quality data to learn from. If the data you feed it is incomplete, messy, or wrong, your AI will learn incorrectly. And no amount of testing can fix a fundamentally bad lesson. As a developer, preparing and understanding your data is the first and most crucial step in building a reliable AI. It's like a chef making sure their ingredients are fresh and of good quality before even starting to cook. Imagine you're studying for an exam. You wouldn't study only the asterisk exact questions that will be on the exam, right? You practice with some examples, your training data, to learn the concepts. Then, for the asterisk actual exam, you get new questions you haven't seen before, your testing data, to see if you truly understood the material. In AI, we split our data, training data. This is what the AI learns from. It's like the practice problems. Testing data. This is kept completely separate and used only to evaluate the AI after it has learned. It's like the final exam. This split is critical. If you test your AI on data it has already seen during training, it's like a student cheating. It might look smart, but it hasn't genuinely learned. Once your AI has taken its exam, processed the testing data, how do you know how well it did? We use metrics, which are just fancy words for scores or measurements that quantify its performance. Accuracy. This is often the simplest. It's usually the percentage of correct answers. If your AI correctly identifies 90 out of 100 images, its accuracy is 90%. This is like getting a score on your test. 90% is great. Error rate, the opposite of accuracy, how many times it got it wrong. As a developer, understanding these scores tells you if your AI is performing well enough or if it needs more tuning to meet your project's goals. Even with good data, things can go wrong. 1. Bias. Asterisk, imagine our robot chef was only trained on recipes from one specific culture. If you ask it to make a dish from another culture, it might struggle or even make assumptions based on its limited training data. In AI, if your training data disproportionately represents certain groups or features, your AI might learn to be unfair or incorrect for others. Rigorous testing helps us identify and mitigate these biases. 2. Overfitting. Asterisk. Remember the student who only studied the asterisk exact exam questions. They might score perfectly on those questions, but fail miserably on any new question that's slightly different. An overfitted AI is too specialized to its training data. It memorizes rather than learns broad concepts. It performs great on training data but poorly on new, unseen testing data. Testing with unseen data is crucial to spot and fix overfitting. Building an AI isn't a one-and-done task. It's like a piece of software that gets continuous updates and bug fixes. You train your AI, test it, find issues, like bias or overfitting. Then you go back, adjust your data, tweak your AI's settings, its code or model parameters, and test it again. This continuous cycle of train to test to analyze to refine is called asterisk iteration. As a developer, you'll constantly be refining your AI based on testing results to make it better, more robust, and more reliable over time. Your AI is a living system that needs continuous care and improvement. As an AI developer, understanding testing and validation isn't just a technical step. It's about responsibility and impact. You're building tools that can influence people's lives, from giving recommendations to assisting in critical decisions. By diligently testing your AI, ensuring its accuracy, fairness, and reliability, you're not just making sure your code works, you're building ethical, trustworthy systems, and contributing to a better, more responsible future with AI. This fundamental skill is paramount to ensuring your AI delivers on its promise safely and effectively. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.